Good afternoon. Welcome to course Thermodynamics of Materials. We are today into lecture 121 and 122. We are discussing assignment number 10. Last day we went up to this point. This point actually we actually had to abruptly stop this. So we complete this. This is problem 1. We are discussing. Problem 1 we are discussing. The problem already given and we are actually halfway solving the problem. First part is already answered. The second part we are considering. Second part, this is solution thermodynamics obviously continued and assignment number 10. That is problem based on alternative standard states, as I have already said last day. And this is the problem 1. We will have about 6-7 problems. So this is the first of this, and we hope to complete all problems today. But let us start with this. What is the second problem? B part. What is the? It says, what is the activity of B at composition M with respect to P? What is the activity of B at composition M? Is 0.5 mole fraction of B. XB is 0.5. What is the activity? Now, since activity, it can be reference to many different standard states. Since choice of standard state is purely arbitrary. Okay? So we can actually choose arbitrarily standard state. So what is this? Matter of choice. So in here, activity of B at this composition with respect to 4 standard states. Problem says with respect to P means 0.4 mole fraction. M itself, Q, next Q, which is 0.6 XB mole fraction of B, and R, the so-called Raoultian standard state, which is actually corresponding to XB is 1. So this line is discontinued. Okay. So this is okay. Hello. Here. So this is actually this line. This line is this. So this is R. So with respect to these 4 standard states, we have started with the first one. Before this, we actually have two things, 2 points you have to understand. 2 points. What is this? I have already said this. Recall this. If you remember this, you will use profusely this one. You will use often this relationship and this relation also. So what I said, I will explain. GI bar is GI bar. Start with this identity. So we get this relation. We are considering 2 standard states. One is standard state 1, another is standard state 2. One may be Raoultian standard state, another may be Henrian mole fraction standard state, or maybe Henrian weight percent standard state. And here, these are purely arbitrary standard states. These are actually for learning purpose. This is any standard state is a matter of choice. So this we want to understand. So this standard state is neither Raoultian nor Henrian. Raoultian is here. Henrian I have not drawn because these are all on the Raoultian line, but different compositions. These compositions. These are the standard states. So standard state 1. GI0 standard state 1, RT ln activity of I with respect to standard state 1. Coming from what? GI bar is GI0 RT ln AI. Remember always this AI. AI has reference to a standard state. What it says and which AI of which state? Your answer is of this state. State under study. Of this state with respect to a standard state. Which standard state? Here. In the sequence, everything is said. It is with respect to standard state. So 2 things. Which state, activity of which state, and with respect to which standard state. Because activity by definition has a standard state, by definition. So without referencing, without giving the standard state, activity, the term activity has no meaning. If you say activity of iron is 0.3, no meaning, meaningless. You have to say with respect to pure liquid iron as the standard state. That is Gaussian standard state. Or for that matter, any Hennian standard state. This will take up all in the coming problems, okay? Subsequent problems. So this you can write, or alternatively you write this transpose gi bar minus gi 0 is RTL and I. This will be also useful, okay? This. Same thing, the side change. Gi 0 is taken to the left hand side. Here likewise here is another thing I am saying. I am considering two standard states. These are actually I am considering, I am writing gi bar in terms of this first standard state and then in terms of the second standard state. So to the left hand side, in terms of standard state 1, gi 0, standard state 1. Can be Gaussian, can be anything, can be this. In this problem with reference to this, can be this, can be this, can be this. 1 good enough. This one is 1 and 2, no more. So gi 0, standard state 1 plus RT ln activity of I, as I have already explained, with respect to standard state 1. Here I said activity with respect to this standard state and of this state. So gi bar is gi 0 plus activity of I at the state under study is with respect to standard state 1. Right hand side similarly with standard state 2 only. So gi 0 standard state 2 plus RT ln activity of I with respect to standard state 2. This we use. Sometimes we will actually, what is this called? Juggle it little bit. If we juggle this, we can take this one to the right hand side like this. Shall I do I have to show this or what you write? So what you can write from this? Oh, I think you will get this. Shall I write this for you? Shall I get this space here or what you write? Just take this gi 0 on the right hand side, nothing else. Take this gi 0 standard state 1 on the right hand side. This is actually just for the purpose of substitution. Right here. We or start here. We will use this. So you will get this. Like all gi 0 standard state in short 1 here. Sorry, not this. Follow this. RT ln activity of AI. Just with respect to standard state 1, I am writing 1. This is this one maybe. This one standard state 1. Okay, this one is a Roman 1 and this is 2. So I have written this one short here. Then equals to what you write? Tell me. Equals to gi 0 standard state in short SS standard state 2 and this will be taken to the right hand side in minus gi 0 standard state 1. I don't need so much space here. Okay. On this you are getting this. I am giving you bracket. Just finish this. So you have followed this standard state 1. Then what shall I write next? This goes to this side plus RT ln plus think I can get here. I don't have to move downwards. Plus, or maybe it is here. Plus RT ln. Oh, I should not write this. This A will be misleading. A is always Raoult's activity. I have not mentioned which activity. Activity of standard state 1. I have not mentioned. Okay, any can be Raoultian, can be this P. So I am very sorry. I'm writing, no problem. I'm writing. Ln, writing this one. Activity of I. Spelling ACT. Activity here of I. Like here with respect to space, standard state SS, so SS standard state 1. That is vitally important. 1. So this I have written here, and equals to this goes to the other side. I am going very slowly because students find difficulty in understanding alternative standard state. That's why I am going very slowly. Okay. Plus RT ln. Why write this? Again don't write A Raoultian only, restricted to Raoultian, and Henry at H. Remember H? Subscript mole fraction or weight percent. So RT ln activity, like this one. Activity of, like this, activity of I, like this, activity of I, like this, with respect to, like here, with respect to standard state SS2. Right. Since I have space, standard state 2. This is this one or. So I will fence this. This is another fencing. Another. Give this. This alternatively gives this. This means this. Okay, clear? So just matter of just side change. I am taking this to the other side so that they are together. Exactly. This I will use now. Now it is ready to use. It is like this. Now start the problem. Give me what I have given you. This and this. This alternatively this and this alternatively this. Just side. Easy. Very easy. Follow this. Okay. Thank you. So start the problem. First problem. What is the value of delta G0Q2P, that is G0P minus G0Q? It was solved yesterday, and answer is RT ln 2/3, temperature T, pressure P. Okay, so it is in terms of T. So this is the answer. Now second part is B, part B. Part B has what is the activity of B at composition M? Given composition M means in the XB is point. XB is 0.5, P is 0.4 and Q is 0.6, and R is Raoultian. Everyone knows XB is 1. Okay, very good. So we are here. I start. I am writing in this format. This one RT, like this. See? Yes, standard state 1 is what? Raoultian. Raoultian is R. Let me do. First is Raoultian, second is I have written yesterday P, second is P. So I am writing full. Activity of whose? Question, 2 questions will ask. Activity of whose? And with respect to which? Or what? Activity of what? So this is RT ln. Question is activity of B at M. M means that is at mole fraction point XB 0.5. So this is activity of B. With respect to what? The Raoultian standard set I have used. R. Means with respect to R, I consider. If it is so, then you apply this. Now it will help you. So this is your 1. So 1, this is 1 Raoultian standard set R, this 1. So it will go to the, this will be here minus G0R. And this is what? Second standard state is what? P. P is the second standard state. So I have written here, you follow this. Please follow here. RT, second one, RT, ln activity of B at M with respect to second standard state is the P is the standard state. Now, why you are considering here writing this? Because for two reasons. People want to say. This is to be found out. This is the question. What is the activity of B? See, what is the activity of B at composition M with respect to P as the standard state? The first one I have picked up. P as the standard state. So I have considered. Then why I have considered this other side? Any convenient one? I consider R because this value I know. Because this diagram is drawn with respect to AB versus XB. AB versus XB. AB is Raoultian activity. So, with respect to Raoultian standards, are very helpful. Follow me. Now follow. I have written next. RTLN since with respect to Raoultian standards, that means remember R. So, activity of B at N. Activity of B, not NR. Certain composition. Not on composition, temperature, pressure. Then activity will fully defined. Activity of B at N. This is what? Since I am entitled to write AB because it is Raoultian standard state. AB at where? At N. So it's okay. Next time here actually I was going to talk that this is how you find. I already gave you instruction. Anyway, forever use this. Never forget how to handle this. G0P minus G0R. Actually, G0P minus G0R. Why it is this is standard state? This is another chosen standard state. Arbitrarily imposed standard state. This is an academic question maybe. Didactical purpose. P. Because that is the question. With respect to P, first one. P as a standard state. So G0P minus G0R means free energy of this state and free energy of this state. That means the free energy of this state minus free energy of this state. When you come across this, you use this please today. Last I wrote. Never forget this one. Remember, I will not remove this because often we will use this. Okay? Or maybe I do not know. If I have to remove, then I will save it somewhere. I have saved these relations and these relations from yesterday. I have saved. I kept it saved and I will use it. So what is this? How will you get this? Follow. All I tell. Suppose Raoultian GI bar minus GI0. Who is your GI bar and who is GI0? Say you consider G0R is the GI0. This G0R plays the role of GI0. Then GI bar is where? This is GP0. Anything. G0P is GI bar. G0P anything other than this is GI bar. Treat it as GI bar. GI bar minus GI0. This is playing the role of GI and playing the role of GI0. This is playing the role of GI bar. Then what is the answer? RT ln AI. AI is what? Activity. Again. AI is the activity of this state relative to this state. Relative to this standard state. With respect to this standard state. With reference to this standard state. So that means what you are getting? Activity of B is a point. Activity of B at P with respect to Raoultian standard state. Activity of B at P with respect to Raoultian standard state. The meaning of this one. Packing from this. 1 to 1. Always use this. 1 if you consider G0. Another is GI bar. GI0 GI bar. Then freely use RTL and AI, which means, I repeat, activity of this state relative to this state. That means this is what? This is RTLN is there. RTLN activity of this state relative to this state. Very easy for us. Relative to this state, these are all in the diagram. Relative to Raoult's center states are AB, and activity of AB at P is given. You can see easily. You know what is the equation for this line? Activity of B is XB, and XB at P is 0.4, and that is the RTLN 0.4. I am writing step by step. So this is what let me write is RT. Tell me RTLN. What is this? Since R is the reference A I am using. Activity of with respect to Raoult's center. The symbol is the activity of B at P. Activity of RTLN, activity of B at P. Okay, what is this? With respect to this only. This only. With respect to symbol A means with respect to Raoult's center state. With respect to R is Raoult's center state. Okay. Plus just what you have done here. You do this is the question. This is the question. So just keep it intact. Plus RT ln. Just like this activity of B at M with respect to P as standard state. Standard state. This is the question. This will find out. So this must be known. Follow me now. Next step. Or RT ln. Once AB you are very comfortable. AB is known. AB at M. What is the AB at M? AB means is this line equation Raoult's law, you know, is nothing but I am giving you a step. XB at M. Since Raoult's law, on the Raoult's law line, this is Raoult's law line, and AB is XB. Okay, very good. Is what? Right here, RT ln activity of B at P. What is nothing but again activity of B at P is what? XB. Again XB. AB, since it is AB is Raoult's law. Okay, already I have discussed this one. AB is XB at P plus I'm just not writing ditto. This is the question. Or keep on writing RT ln XB at M. Tell me what is XB at M? 0.5. The M means XB at M. So 0.5 is RT ln XB at P. XB at P 0.4 plus ditto. I'm giving this, but I'm writing once more. Give a star mark here and go to the top. These are not needed anymore. Okay? Solution is continuing. These are not needed anymore. This part is over. So continue. You have give a box, you save this. Not only this, but this is in the middle. I do not know how shall I save this, but I do not know. Let us see. Let's go ahead. So if you remember nothing like that, if you follow this, because if it is written here, then it is easier for me to show you how it is true, how the lines where I am developing. So if it is not there, then it will be more difficult. Okay? It may be a little difficult. Okay? So follow this. Star is what? I am repeating this. Or clearly I am writing RT once more. ln 0.5 is RT ln 0.4 plus you write it now, write RT ln, write this RT ln, then you write this activity AC. I think you don't need this, na? This problem already given to you, no problem. And this second part is okay. Second part, first part, even first part you use this. Okay. RTLN, let me copy this nicely. Activity of B. B is the species at N. At N, in fact, still you can write at the state M. Still, I don't have space. Full means full expansion is activity of B at the state M. State, otherwise you don't understand. Activity at a certain state. Activity of a species at a certain state. At the state M, state is composition. State is given by composition, mole fraction, temperature, pressure. So at state M I am not writing. At composition M, I am writing at composition M. Have I written? I didn't have much space. I am writing now at composition M. As the question asks, at composition is state. M with respect to, tell me, follow. With respect to P as standard state. Right here. With respect to short, with respect to P as standard writing here, since I have some space now. Simple. First thing what you will do, or you have to find this. This is the question. See, activity of B at composition N with respect to P as standard state. So this is. So you first do RT cancel. RT. What it is? ln. Take this side. 0.5 by 0.4 is ln activity of P, etc. I will not waste time on this. Dot. Because or you write this ln cancel, or you write this now free. Last line. Or activity, write full. Activity of B at composition means state, at composition N with respect to P as standard state. Achha, why I am not written S? Why I wrote ACVITI, ACTIVITY activity, not A? What is the answer? Because it is not Raoultian reference. Raoultian state with respect to not Raoultian standard state. It's P as standard state, for which I don't have any symbol. So write in language. The symbol A is reserved for Raoultian. Then you don't have to write that with respect to Raoultian standard state. This automatically implies. This implies that it is Raoultian. Similarly, Henry's. These symbols we already have. Otherwise, we have to designate some symbol. We have to give some symbol. This may be maintained in the next problem. Coming to this. So that's why I have activity of B. And here also given activity of B. Act P with respect to P as P as standard state. As write nicely as standard state. What is the answer? Sir, what is the answer? With respect to, it is better I write here. 0.5 divided by 0.4 is 1.25 answer. The box here. Happy? Okay. Next is B continued. Next is what? I'll take up Q and then I N, then R. Q. Since P is 0.4, Q refers to 0.6. Q corresponds to 0.6 XB. So next similarly, I will not go through these steps unnecessary. Okay, you tell me activity. Next one, the Q I am taking up. Okay, activity for some reason. Okay, because this I have just now completed, so it is better I show you activity of just B at composition M. At composition M with respect to what tell me? Q as standard state. Q as standard state. What is the answer? You can tell me what is the answer, what is the difference? Other things all remain same. Other things remain. So what you do here? Why you start here? You have started here. Started. Activity of B at M still remains active. All you have to answer activity of B at M. Only difference is with respect to P standard state or next M standard state, M as standard state, Q as standard state, R as standard state. So is all you start having like this. I am not doing this. I am giving you the hints. RTLN activity of B at M. That's the question. With respect to Gaussian, again you choose the first one is Gaussian, no problem. And then you apply here instead of P, what you write? G0 minus G0 plus RTLN, etc. with respect to M. I am very sorry. Which I consider Q as standard state. I am considering Q. Very sorry. I repeat. I am very sorry. Start. I will start RTLN activity of B at M with respect to Gaussian standard state. Because that is M activity of B at M is the question. Is what G0 P no. This time G0 Q minus G0 R plus RTLN activity of B at M, again at M, with respect to not P, with respect to Q as standard state. And this is to be found. Same. You understand what will happen actually. What will happen, which will change? XB at Q, XB at P will be changed to XB at Q. Other things remaining same. So it will be 0.6. So answer will be 0.5 by 0.6 is what? 0.83. And what will write here? Answer. Second one. Third one. Next, third one. But the next is with respect to, right here. You may be right. Next is with respect to Q as. Last is right. Activity. I'm right. This way I'm right. You see, there is some interesting thing. I'm taking up which one next? M. P is over, Q is over. M. Activity of B at composition M. Tell me with respect to here, P is there, Q is here. With respect to now the turn of M, with respect to M as standard state, what will be your answer? Activity of B at M with respect to M. Activity of M with respect to M. Activity of pure iron with respect to pure iron as standard state. One. Same thing. Numerator and denominator same. Reference and the state and the study and the reference same. So what is this? Activity is 1. In this language it is 0.5 by 0.5. You see 0.5 by 0.4, 0.5 by 0.6, 0.5 by 0.4, 0.5 by 0.6, next is 0.5 by 0.5. Ridiculous. Okay, ridiculous means, okay, very easy, so easy, you don't have to, it is Always true. Activity of liquid, pure liquid iron with respect to pure liquid iron as the standard state. Answer 1. Activity of pure oxygen at 1 atmosphere with respect to pure oxygen with pure oxygen at 1 atmosphere as standard state is 1. The moment reference changes, activity will be different. Okay. So this is reference and state and the study same. So if these two are same, if these two are same, like here, if these two are same, what is the result? 0. And what is the AI? 1. Forever. Forever. Don't ask anyone. Okay? It's forever. Okay? So this can I give this? This so is the last is also equally easy. Equally easy. So I think I am writing here. I don't want to disturb this, but I can disturb this part. This part. Give it here double star to show that I will continue here. What is here? Next, still next, because there are 3 down, P, Q, M down, R, and it is also very easy. So let me write this, and you answer this one. I am writing next activity of B at composition M. Composition M, sorry. With respect to who has standard state? Last is R. R means Raoultian standard state. Shall I write here? Raoultian standard state. R is what? Raoultian standard state. This we know. And this activity of B with respect to AB means with respect to Raoultian standard state. So let me write with respect to, what shall I write? With respect to R as the standard state. R means as standard state. So what will be your answer? Is nothing but AB. Raoultian standard state symbol AB at M. What is that? XB. AB is AB I have used AB at M at composition N is M with at composition N is XB. AB is XB. Raoultian line equation. Okay, AB is XB. I have already used here many a time here. Activity of this. AB is XB number of times. Okay. So anyway, you see this. Okay, I have named this XB at M. And what is this? And what is this? XB at M? The point. Easiest answer. So answer 1, answer 2, answer 3, answer 4. I am just summarizing it, this code, for some additional discussion. Okay? You expected this type of result, as if you expected this result. You can justify, you can defend your result. Okay? See, I'm showing. So what is this? The answer. So this I am not considering. You don't need actually. I am actually here. Table. Kind of table. This additional top. Problem is solved. Answer 4 answers, all answers are given. Problem solved. But additional top, okay? Note. Table. Additional explanation. You follow this. With the help of a table. Very nice. I am writing the question. Activity of B at M, let me write. Activity table. Activity of B at M. Short time, with respect to P as standard state. With respect to P as standard state. Oh, I should take P as standard state. What is the answer? Give me the answer. P is 1.25. Next, activity of B at M, same with respect to what? Next is M as standard state. Okay. Go this way. Go this question also. P and Q bar M. Although I solve it. Okay. After the first two is actually on the third. Okay. Yes, third case. Not the second case. But answer we know. So I am writing here as standard state is what answer, right? 1. I write 1. This is not 1, not fair. 1. Just 1. Activity. Next is what? Tell me. Okay. With respect to PM, with respect to what? Q. Q as standard state, what answer? Tell me. With respect to Q, what answer? Q. Actually, similar. I told you, 0.86. Activity of last one at M with respect to what? R. So for all standard state as standard state, what? Tell me what value is the last one? 1.5. What do you see? You see a trend, pattern. See, gradually decreases. 1.25 to 1 to 0.83, 2.5. Why this happens? This is expected. Why, sir? Why this is decreasing, sir? Activity of M, B at M, with respect to P, with respect to M, with respect to Q, with respect to R, decreasing from 1.25 to 1 to 0.83 to 0.5. Why, sir? Follow this. You will very easily find this. I'm explaining. Why this trend? Why this trend? I'm answering you. Why this trend? Answer this. Follow this line. You will get the answer. GI bar is GI0 LNAI. This principle you will use throughout all problems for your own understanding. When you are alone, you are with yourself. This concept, this is full of concept. So you will use this number of times, and for your satisfaction, for your confidence, I am telling you what. GA bar, see what is changeable you have understood by this time. State under what is this? Activity of B at a composition M means at a certain state with respect to certain standard state, some standard state. And that can be varying standard state. So this is subject to variation. At least in this problem, we are considering 4 standard state. So this is subject to variation. This is not. GI bar, that is the state under study. What is the state under study? Activity of B at M common. This is state under study. That is GI bar. So this is common. Now with respect to the standard state means GI0 term is taking sometimes this P as the standard state, sometimes M, next time Q, next time. So these changes now tell me if this is fixed. Right? Fixed, given. fixed or given at m, given, if this increases as the standard state changes, free energy changes. So if it increases, what is the trend? AI will decrease. So Gi0 increases, AI right here, right? Gi0 increases, AI decreases. Hence AI decreases. So Gi0 of increasing in this way. Again question, sir, why Gi0 means free energy? These are all our standard state I consider 0. So free energy of this state, why sir this is increasing in this direction, so that activity has decreased? Why free energy increasing? Remember, free energy and activity intertwined. It is through this cardinal principle. From this we are getting this GI. Remember, we started with this DG is RTD, LNF. So from which you get activity. So this is the activity initial relation, defining relation maybe. This is the defining relation. But in the next step we get from the DG is VDP minus STT, and DG under constant temperature is VDP, and then RTD, LNF, and then we enter into activity. So, sir, question very good, sir. It is accepted, sir. If it is constant, fixed given, then it increases. Sir, why this increasing this direction? Best question. So what happens? Why free energy of this increase? Free energy and activity intertwined. If free energy activity increases, free energy also increases. GI bar, although I am showing this, yeah, these are all actually not this is considered standard state. These are not non-standard state, but I impose them as standard state. We have actually considered, we have pretended these are the standard state. This is fine, no problem. This academic very good academic consideration, very good. Okay. So what I am saying, why the free energy? So as this is the answer I am giving you. As activity increases, free energy increases. This is another. So this part is over. Now next question is, why sir free energy of this, say G0, because this since you are referring to what? Standard state. G0P, G0M, G0Q, G0R. Why increasing, sir? The answer, activities are what? Activities are increased. See, activities, say 0.4, activities more fraction. 0.4 to 0.5 to 0.6 activity. If activity has increased, GI, free energies also have increased. Free energy of this, free energy of this P is less than M, which in turn is less than Q, and which in turn is less than R. This is the greatest, this is the lowest activity. With respect to say Gaussian, whichever, same reference, you are different activities, and one from smallest to highest. So if this is increasing, then activity will be decreasing. So this you try to always follow this is the follow. Where I have shown GI bar minus G, or here it is better here. Increasing, decreasing. You will get this one or two problems later. We'll consider solid and liquid. This is standard state 1, standard state 2. Now next or later in the next one of the next problems, or quite a few problems, you will see solid is the 1, liquid is the 2, or liquid is the 1, solid is the 2. Pure liquid iron, one standard state, pure liquid iron is one standard state 1, pure solid iron is standard state 2. Pure liquid vanadium as standard state, pure solid vanadium as standard state. So two standard states with liquid and solid, and which have actually free energy. Okay, in which context I said this? Actually, this is very important. I wanted to tell you. You have to consider that which has higher free energy. And finality, easy way to get the answer, quick way, which are more greater activity, greater finality. Like this, from this. Greater this, greater this. Greater this, greater the activity increases. So this is standard from coming from the activity increases. So activity increases, finality increases. Finality increases means this term increases. And that correspondingly AI increases. So no surprise that we got this answer. Thank you very much. With this, we have completed with the additional discussion problem 1. Let us take a problem 2. Okay. Thank you. I'm removing all this. This all. This all. This I am not doing. Oh, sorry, I removed this. Anyway, I will write once more. I will write here. I am very sorry. This will be used. I am sorry. This one, this middle one. But I wrote again actually. Hence this you written. You don't know when you use this. Okay? First of all, complete problem 2, then 3, then 4, 5, etc. So I am writing this. What I wrote here, I am sorry, I am actually wasting time. I am very sorry. What I wrote, tell me. I am writing this. This what I wrote quickly. Gi bar is Gi bar. This identity. Or I am writing these equations in terms of standard state 1. Or Gi bar is Gi0 plus R3 ln AI 100 times. You have use this plus right Gi0. You are giving this standard state 1. Plus, right? Gi0 first, we are working on the left hand side, actually. Gi0 plus RT ln. Don't write a activity of I with respect to, tell me, standard state same means 1. As I don't know right hand side, I know only this. This means this. This is this. This is the state under study. So state under study, both sides. Gi0, how will you express this? Arterial activity of I at the state under study. As I showed you, remember, never forget. State under study with respect to this standard state. Never forget this. So I have written this one, and the next one you write what similarly is Gi similarly. Gi0 standard state subscript standard state what? Tell me 2 plus RT ln again activity ACVITI. You don't know what activity of I with respect to standard state. This is 1, this is this side 2, both 2. Or still this is 1, this is box, this is box. Necessary. I am repeating, since I am writing, I am repeating. Actually, I am very bad habit. Okay, I repeat. What can be standard state 1 and standard state 2? You will answer. Standard state 1 may be Raoultian standard state. Standard 2 may be Henryan standard state mole fraction, or Henryan standard state weight percent, or maybe standard state 1 is Henryan mole fraction standard state, and standard 2 is Henryan weight percent standard state. These 3 standard states we have recognized this. These have been popular, I think. Raoultian most popular. Okay, physical state. Remember, physical, pure iron. But it is not pure iron. Henryan standard states are not pure. one mole, they call one mole fraction standard state, non-physical. It is along extrapolation of the Henry's law line. After these are all discussed. So this is one, this is two. What other examples are you have? Another example, standard state. The first one is solid standard state, pure solid standard state. And what is the standard state? Two are liquid, pure liquid standard state. And we will use this. There will be no mistake. We will use this solid liquid. Or what I said, tell me. Since I wanted to group, remember I want to group these two, so I take this to the right hand side. So in short I am writing RT ln, right? Activity of I. Again remember, short activity of I at a certain state. This is not written here, but it has to be. A certain composition means state. Activity of I have not written. With respect to, right, what's it? Standard state. Sorry. With respect to standard state. Oh, standard state, sorry. Standard state 1. Keep it here. Is take to this and group them together. Looks very nice. GI 0, standard state 2, minus GI 0, standard state 1, state 1, plus trigonometric RT. It is taking too much space though, but what shall I do? I don't know. But otherwise you will not be able to follow my class. So I am saving this. Box plus RT ln ACTIVI TOI, which is activity of I with respect to standard state 2. That's it. So, or box this. Sorry. So these are saved. Now utilize the remaining space for solving problem. Okay? Or this. Okay? Maybe I will do this later. Start problem 2. What shall I write? Problem 2. Shall I write? Well, this is the solution side. This is the problem 2. Let us try this. Okay? I cannot remove today. Okay? Let us hope once these are over, then we will actually. So let us write the problem 2. Good, very good. The AB XB, AB XB relationship, activity composition relationship, the AB XB relationship for the alloy AB, for the alloy AB. Very good. For the alloy AB is given by the factual term. By the factual means actual, means experimental. The factual curve. What is the name of this factual curve? AWMR. Sorry, R. You all case is okay, AW in a in figure 2. In figure, oh sorry, this previous figure was figure 1. I go perhaps figure 1. Okay, this is figure 2. Figure 2. So this is actually in figure 2. Why you are in figure 2? We propose again. We propose a new standard state. A new standard state n, that is n. It's better I draw this. I draw this, okay? It is better. I draw this. Yeah. I draw this where? I draw this here. Here. I draw this. Draw the problem. Figure 2 I am drawing. Figure 2 I am drawing. Figure 2 I am drawing. What is this? AB. AB goes to, as you know, 0 to 1. You know XB will move from 0 to 1, and of course this is the Raoult's law line. Not good again. Just like this was straight line. Good enough. Good enough. This is Raoult's law line, as you clearly understand. This is the XB, AB is XB, Raoult's law line. And what is this next? Then deviation from Raoult's law. Okay? There is a deviation from Raoult's law. See, initially goes straight, as it goes straight, then takes a bend, turn, merges with the Raoult's law line. Okay? So this is actually, I tell you what, the name of this curve is A, with W here, W, the N here, N, and R is the Raoultian standard set, that Raoultian standard, like this, capital R, lowercase, uppercase, lowercase, anything, R, Raoultian standard set. What is, if you actually extrapolate this linear part, which is Henry's law, linear part, extrapolate, it is all given to you, extrapolation. This Henry's law extrapolation. Then what is the name of this? This will be HBMF scale. Okay? 1, this is N, remember this is N. Right here. This is N. N is what value? N is what value? 3. This is given to you. This is 1. Which scale it is? HB mole fraction scale. Remember scale? Y-axis, parallel y-axis. This is AB scale, Raoult's activity scale. This is this. This is the point N, very important. So what is this called? A, W, N, R. This is Raoult's law. Rao's law. R law means AB is XB. Okay, I am not writing this. This is okay. This is the Henry's law line. What is this point? What is this point? Remember what I said? Yeah. What is this point? Okay. Henryan standard state mole fraction. Or if you call this, what symbol I use this? HBMF perhaps. Henryan standard state. This is Henryan standard state. Okay? This won't have okay? HBMF, you know, this is Henryan standard state mole fraction. Okay, this is the standard state. That's why Henryan, in the Henryan scale it is 1, this you already know. Only given thing is this is 3. This point corresponds to Henryan scale, corresponds to 3 according to the Henryan scale. This point. And this is our proposed new standard state. New standard state. So, okay. This. So there is another point 1, you know, 1 corresponds to what? This will be important. W at 1 weight percent B. 1 weight percent B. Right? 1 weight percent B. This is the name is W. So A, W, N, R. This is the deviation from Rao's law. And the initial linear segment is Henry's law. And this is the extrapolation of Henry's law, as you know. You call it, the name is HSS mole fraction. Nickname, you can use, I will shorten it, but this is the Henryan standard state, mole fraction wise, mole fraction Henryan standard state. This is another is weight percent Henryan standard state, but it is not required. Now let us read the problem or write the problem. Okay, we propose a new standard state N corresponding to, oh, there is also something here, 0.8 corresponding to XB is 0.8. So this 0.8, XB is 0.8, and what is the other information? This value in the HBMF scale, Henryan standard state scale, point is 3, just 3. This information are given. One is everyone knows this, so this is redundant, but you may know this is the Henryan standard state, and hence the according to Henryan standard state scale, this is 1. It should be 0.8. That is this 0.8. On the factual curve. On the what? This is the factual. What I said, A, W, N, R is the factual, means actual curve. On the experimental curve. On the factual curve. On the factual curve. Find out. Find out the activity of the B with respect to this new standard state. With respect to this new standard state. New standard state. New standard state, call it symbol, a symbol. AB, no, AB cannot be new standard. This is a new standard. So Raoulsian is here. No, AB is for Raoulsian standard. No. So new symbol AB prime. No problem. AB prime. You can use call it AB prime. With respect to this new standard state. at the state where activity of B at which state? This is with respect to. One is with respect to is okay. Of which state? At W. The state W. Find the activity of B with respect to activity of B at W with respect to N is equals to activity of B at W with respect to N, and these W N all lies on the deviation from Raoult's law. One of them is sitting on this Henry's law, another is sitting outside Henry's as well as Raoult's, of course, deviation from Raoult's. This is the problem I'm writing this. Completing, okay? So find out the at which state? At the state given by W. That corresponds to certain composition at that composition given by W. At W means the composition W represents. At the W at this composition is there. 1 weight percent. See W at 1 weight percent. This is explicit though, but this is 1 weight percent. Yeah, you can easily convert weight percent to mole fraction and mole fraction weight percent. Anything you like. Interconversion, you know. From very beginning, first class of solution thermodynamics. Okay, very good at one, and okay, very good. Still here. Interconversion. Okay, yeah. At 1 weight percent, very good. Then what? On the Henry's law line. It is on the Henry's law line. State under study is on the Henry's law line. Is the Henry's law line? Henry's law line. So on the Henry's law line. On the Henry's law line. Very good. Given atomic weight of A is 56 and atomic weight of B is 28. Now this is the question. Very good. Huh? So you could guess which is a iron, which is B, 28 atomic weight, silicon. Okay. So the question is clear. So simple question. What is the activity of W with respect to N? As can understand. With respect to this, as can understand. Start. Solution. Okay. Start like this. Okay. To start with this, delta G0 into W is what? We'll ask the also N2 W. Say N2 W means this is the process N2 W. So product minus reactant. So G0 W minus G0. Happy? No problem. This reaction delta G, no? So N2 W. Product minus reactant. So write nicely. Don't write N G0 N minus G0 W. Oh, then you will screw up. So careful. G0 W, but if necessary write this way. Product minus reactant. So then I'm keep on writing. I'm doing some juggling, manipulation. What I'm writing, this is question is activity of B with respect, okay? So G0, I'm writing this, you follow me. G0 W minus G0 H. Achha, this point symbol is H. H. What is this? Henrian standard strain mole fraction. One mole fraction standard strain. H. R, Gaussian standard state. Henrian standard state H, lowercase. Gaussian standard state lowercase r. No, does not matter, lowercase or uppercase. H. Since that, okay, like this. And what is this value? You can write scale wise. This is the 1. You know, this is the 1. Just little bit. This is the 1. Scale 1, 3. And of course, this is 0. You know, this is 0 also. We are interested. Obviously, HB is mole fraction. So 0. This is the everyone knows. What is the equation of this line? HB is mole fraction. You remember HB. HB is XB. Okay. This and this line everyone knows somewhere. HB is XB mole fraction here. Okay. So, but anyway, this one is the value of this scale value 1. Very good. 1, 3. You understand nothing like that. Okay. So I am subtracting G0 of this. G0, why G0, sir? This is the. This I am trying to find out. This of this state G0 W minus G0 N. Okay. Say G0 N minus G0 W. Okay. It's okay. You follow this. Minus G0 N. You may argue that N is the standard state chosen, but W is why? This is a state. This is just at any state. New standard state is N for new, maybe. New standard state. And this is W is another state at which you have to find out the activity. So I have called it G0W, you may call it GW, does not matter, okay. So then I have to carry out this, okay. So you may consider this actually, this is another state, does not matter whether it is another standard state or just a state, okay. So I'll use this relationship, okay, I'll treat this as GI bar soon. Okay, here, this is our time. G0W minus G0. If it is G0H is fully no, you know, this standard state. This is what? Anything other than this is GI bar. If it is GI0 accepted, anything other than this cannot be G0 anymore. Anything, if it is then this activity result will be 1. So that is different. So this is treated, this is playing the role of GI bar. This is playing the role of GI bar. This is playing the role of. Be used to this. Often. Then what is the answer? R3. Here I actually consider I wrote A means because I consider this is Gaussian standard state. I write here, otherwise it is not difficult. Because this symbol AI reserved for Gaussian. Okay, but since previously we didn't have only Gaussian, so that's why we didn't mention this. But now since there are a number of alternative standard states coming, particularly 3 are coming. Okay, and solid liquid 5 will be coming. Okay, so we should be careful. So this is GI bar. So 0, if you write GW does not matter. Okay, 0 this 0 superscript 0 if you remove does not matter. But use consistently that it is GW. Okay, but anyhow finally it is GI bar minus GI0 is RT activity of I again activity of I at this state relative to this state. So what it is? Tell me. RT right, what is this? What you write? Activity with respect to this state, what is the symbol? This is Henrian standard state, H. What is the symbol? HB. Shall I write anything? But I will correct. HB where? At W. Composition. GI bar minus GI0. Is RT ln AI. RT ln AI. AI is that activity of I. Activity of I with respect to this standard state. Here with respect to Henrian standard state. And what is there is a special symbol for Henrian standard state. Special status. Like Gaussian. Gaussian is A, B, Henrian is HB So HB I should write. It is better I should write HB since only one is there. There is no write this HB MA at right where of this state of GI bar, activity of this state relative to this. So, and since this is Hennian activity of this state or activity of this state relative to Hennian standard state, mole fraction. So symbol is HBMA at W. Very good. This part is over. Similarly, tell me what is this one? Tell me similarly write. Actually minus I am writing here. RT ln. What is this? Tell me. HB again. HB MA where at N GI bar here AW GI bar minus J0 at A. Fortunately, you know this value 3. So this is known. Okay, very good. Now what is this? Continue. Can anyone tell me at W falls on the Henry-Stowe line? What is the equation of the Henry-Stowe line? I am not writing this. You know, HB is XB. HB is XB. So what is this? That is since W falling at W, the first one. So HB MF is XB. MF is XB. Henry-Stowe line equation. XB at W. XB at W. So this part is over. Next one, what you write? Minus RT ln. What you write? HBMF at N. You clearly see what is the HBMF scale. Give it to a problem. 3. RT ln 3. No difficulty. Now keep on. Okay, very good. Very good. Okay. So what is XB at W? How do you get? What is given about W? 1 weight percent. So convert into XB. How do you convert? XB and weight percent relationship. Recall this. So shall I write this? RT ln XB. XB is what? This relation. Write this. Atomic weight of. This is the reason I saved this. If I had not saved, I would use this relation. Okay. Just I will give you the relation. Then you will not follow. I would, if I had said only atomic weight, 8%, previously I told you, it's better I show it. You will get it if you actually look back at it. What is this called? Backward. Pull the video, you actually back to the what is backward actually to reverse what is this called? Move it backward. Move the video backward, you get this. But you have to move back and forth. But you within that. Write this. Atomic weight of A, weight percent B, divided by quickly. We are all set, almost done. Weight percent B plus atomic weight B weight percent A. Happy? So HB is over. What is this? You write where at W, that is right here. What is that? W means that is 1 weight percent. So you substitute 1. That is at 1 weight percent. Shall I write here this side? At 1 weight percent. This is the problem area. So do this. Oh, sorry. This part minus, right? Minus. This is as it is. RT ln. Carry on. Is quick. RT ln. April. RT ln. What is this? Weight percent B is 1. So this is 1. Shall I write here? This is 1. This is 1. This is what? If weight percent B is 1, what is the weight percent A? 99. 99. So write this nicely. What you get? Atomic weight of A by atomic weight of A plus 99 atomic weight of B. Minus RT ln 3. We have this temperature RT ln 3. Okay? Okay, very good, very good. Shall I find, let us get this as a RT in common maybe. RT in common, na? Common, right? Common. And what is this? Ln. Atomic weight of A is 56. 56 by 56 plus 99, 28, it's okay. Minus RT common minus ln 3. Happy? Achha, by the way, now take up this. So you write here. So I should have written actually. So this one. Starting this one. This one is continue. So GW. I am writing again. G0W. This actually you can avoid this standard state because we have not mentioned that this is also a standard state. Just any state. A state GW. No problem. In fact, I will consider this. This is actually this is GI0, then this is GI bar. Okay. Don't worry about this one. It can be G0. Okay, I am writing here. You can write. Sorry, you can write GW also. But actually, since delta G0 I wrote at the beginning, then actually I should write delta G. Okay, but it is state. This is DW, this state. Whether it is a new standard state at that time or main state, so it is better I should not give a super state. Superscript 0 for a standard state, any standard state, any proposed standard state, any existing standard state, any established standard state. So G0, I will keep on, okay, but don't worry. This I will have to G0W minus, tell me G0 N. This is okay because we know N is G0 N. N is the, yes, it is mentioned, N is the new standard state N. So G0, this is fine. Okay, but anyway, you G0, okay. Okay, so what it is this. Okay, what is this? We crack this. What is this? G0W also minus G0N. What I said? Suppose this is the standard state, playing the role of GI0 again and again, still again. Playing the role of this, I'm sorry, playing the role of this, playing the role of this, then this is anything but this. 0 or no, ordinary, no problem. Non-zero, just ordinary GW. It is playing the role of GI bar. Follow. So GI bar minus GI0. What is the answer? This is actually written in AI. Don't worry. What should be written actually? Shall I have written anywhere? Actually, I have written here. This is actually I have written in full. It is actually RTLN. Tell me what the answer? Activity of I. RTLN activity of I with respect and this state relative to this state. Repeat, is what? RTLN activity of I with at this state. Activity of I at which state? At this state. At this point. At this composition. At this state. Relative to this. So apply this here. So this is nothing but RTLN. I will not use AI. Don't worry. These lessons actually were written when we have only one standard state. Gaussian. So AI I wrote this. Okay, but and we consider that this is the Gaussian standard state. Okay, but in RTLN, write nicely activity, right? Activity. Don't give symbol. Oh, you can give actually, but that I will do again. So they have said some symbol. Where call it any prime. I'm coming to this. let me write activity of B actually at the state W at the composition W at W B at W at the composition W at state W at the composition W activity of at this state with respect to what? In respect to N as standard state. See, calculate, find out the activity of B with respect to this mean state, with respect to N. And where? At the state given by W. At the composition of states. Composition of given by W. At 1 weight per. What is that? 1 weight percent. At the state W, and at the composition of W. Since it is at the state, so write at the state given by W. At the state given by W. Given means at the state having the composition of W means 1 weight percent gets raised. So if you write this at the state, I repeat again, activity of I at this state related to or with respect to this standard state. So similarly, is RTLN activity of this state means activity of B at the state given by W. Here also. At this state, activity very short. Activity at this state related to this state. That is the question. Activity, etc. At this state, activity at this state with respect to the new standard state. So first with respect to, then you give the at this state. So activity of the at this state. This is the question. So this side is what is the time?
1 hour 32 minutes.
32 minutes.
1 hour 32 minutes.
Done. So no problem. At is what? What is the answer? This is the question. This part is the question. Find this. And what is this? RT. You write this. RT ln. What is this much? 56. What is this? If you do this, you take this 3. So okay, this is what? This is 56, but this is actually 2828, and this is minus ln3 means divided here. So all are taken care of. Next is R3 cancel, ln cancel. Your answer is this. What is the answer? So is what? So right. So activity. Shall I write? So activity quickly. Activity of B at the state or at the composition or sometimes at W means implying that the composition that W stands for, the state W stands for. At the state, the way the question is given at 1 weight percent state at the state given by W. So at the state given by W with respect to this new standard state. Sorry, don't do it. Achha, what is this? Unnecessary, I don't have to write. In fact, like how again here, this symbol is giving what? What is the symbol? This is what? What symbol? This one? Call it AB prime. Call this one, okay? Don't do it. Don't do it. And they say don't complicate. Don't complicate. The problem is solved. So once more, right? Finally, so activity. So what is this? this is what? If you do this, 20 actually, if you do this calculation, is 6.6 times 10 to the power minus 3. Okay? It's okay? 6.6 times 10 to minus 3. So this is the answer. So activity of B at the state given by W with respect to N as standard state is 6.6 times 10 to the power minus 3. Okay. So this is the activity at the state given by W. Actually, it is given with respect to first, then is given at this state. Given by at the state here, later on. So first with respect to, then later on. I am saying at the state first, then with respect to the second one. At the state given by W, means at this state. The question in short, what is the activity of B at this state relative to this state in N? At this state with W, so what is the activity of B at W with respect to N? This is the question. This was the question. Thank you very much. 6.6 times 10 to minus 3 is the answer. Move on. Okay. Sorry, we actually could manage actually all these things. Okay. So remove this. Next problem. Problem 3. So we have managed. Again, we start. Problem 3, what it says. Let us see what it says. Problem 3. These first two problems, just to give you actually the truth, that these first two problems, 1 and 2, that we solved, actually these two problems were designed by me. These I designed myself. The remaining problems coming 3, 4, 5, 6, okay, like this, 3, 4, 5, 6, right. These 4 problems I have taken from Gaskell, dear Gaskell, second edition. I will refer to this. This I will not refer because this was actually designed by myself, okay. So start. Problem 3. Problem 3. Okay, very good. A. Calculate when I don't give any reference, means there is problem is designed by me, and otherwise I will give the reference always. Like the references like dear Gaskell, my professor actually at Purdue University, with whom I did my PhD back in 1986 to 1991 February. So like this, 4.5 years. So there, then what reference are Junior R. Seumann or H. Seumann. Okay? That also I have referred. And incidentally, he was in the Purdue University also, emeritus professor, great man. And third, perhaps I have given Morris name. But I asked him to check actually. But always I will give you the references from where I got. These are all the problems that I discuss with the reference. All are actually what problem? What problem? The exercise problem. Means solution I have made actually. Answers are given, not always. Gaskell has given the answer. Seumann didn't give the answer actually. So, but I solved these problems, okay. But if it is worked out, then I will write worked out. For example, in Gaskell, worked out in phase equilibrium I wrote worked out problems. Like say phase transformation of diamond graphite, this I said, and the beam vapor pressure problem, worked out problem. This I mentioned. So I will I'll be truthful about this. I'll be frank about this. I should follow the actually the decorum that to acknowledge the source person when I take this. This, for example, I take from gas scale. Calculate gamma V0 with respect to liquid volume. Liquid vanadium as standard state. Actually, with respect to means as standard state. This is not written in Gaskell's book, but I am adding this. Some addition so the student understand the problem. Some editing actually I have done. Small, very small, just for the clarity of the problem. Like here it is as standard state. With respect to liquid V as standard state, then you understand. And what else? And gamma V0 with respect to solid V, solid vanadium as standard, as well as standard state, as standard state. That's better, I actually standard state. Very good, as standard state. At 1600 degrees centigrade. Okay, quickly. Using the following two data. Two data on the change of standard state. B liquid goes to B 1 weight% in liquid iron. Henrian standard state. If you know this Henrian standard state. What is the B liquid means? Pure liquid means what standard state? Raoultian standard state. This is Raoultian standard. This is easy. This I am writing for you. This is Raoultian standard state. This is Henrian standard state. 1 weight%. Henrian standard state. For the delta G0 is what? Giving to you. Tell me. Delta G0 is what? Minus 330 80 minus 37.57 T. This is the data. Next data is given simple V liquid to V solid. This is phase transformation. Solid to liquid, liquid to solid. Delta G0 is what? Delta G0 is what I say. Very good. Minus 17,600 plus 8.04 T. Joule. Give Joule. Okay. What else? Very good. Giving atomic weight of iron, how much? You know, 56. And atomic weight of vanadium, 51. Nothing else, okay? This is the first part. Then second part is actually I'll take up later. After first part is over, then maybe I'll take up this, okay? Second part. Very good. Second part. First finish this. What is this? You tell me. Solution. First finish this. Solution. B next. B later. I'm giving this B later. I'm writing here also acknowledging from B I write later. B write later. From here Gaskell second addition, page 518. Okay. The book. Introduction to Thermodynamics of Materials. Solution. See, if this is given to you, so what is this? What is delta G0? Like this, delta G0, normally with respect to liquid. Okay, first one which was to be liquid, very good. Write this. B liquid, I am writing, repeating again. B liquid goes to B 1 weight%. B liquid iron, Indian standard state. Is it right here? Gaussian standard state. Pure liquid, Gaussian. Pure solid also Gaussian. Okay. And 1 atmosphere gas is also Gaussian. At the temperature of pure oxygen. 1 atmosphere pure oxygen is Gaussian. Pure liquid, pure solid at 1 atmosphere. At 1 atmosphere. But pressure is not same, also influential. But to be exact, it is pure state under 1 atmosphere and at the temperature of interest is the standard state, the conventional or Gaussian standard. Delta G0 is, let me write this, delta G0 once more quickly. This I want to finish at this minus 17,600 quickly plus, see, silly, it is the top one, minus 33080 minus 37.5 T, just T, A plus BT form, T joule, quickly. What is this delta G0? So why it is for change of standard state? This is one standard state, this is another standard. In the second also, this is one standard state, this is another state. Both are Gaussian, but one is pure liquid, another is pure solid. This is actually something phase transformation change. But now actually in the light of standard state we can also discuss this. Okay, but this is one standard state to another standard state. This is like this you have already used this type of relation. Phase transformation, solid to liquid, solid to vapor, liquid to vapor. But anyway, first to consider the first part. What is delta G0? Can you tell me what is the difference between this? Remember, this is Hennian 1 weight%, and this is Gaussian. What is the relation? RT, tell me, RT, ln, if it were Hennian mole fraction, what is this? That you remember, easiest. RT, ln, Gaussian to Hennian, mole fraction, RT, ln, gamma B0. RT, ln, gamma B0, what is this? This RT, ln, gamma B0, what is this? Is this written here? Is it written here? RT, ln, gamma B0, RT, ln, gamma B0. And using this, actually you get this relationship actually. So it was already used. Remember this, RT, ln, gamma B0, recall this. Go back to this difference and D0, RSS, this actually change of standard state should be somewhere. This is AB. And this is actually it is hitting here. It is hitting here. RTLN gamma B0. It is here. This side RTLN activity, this if you multiply by RT and make it LN, then it is actually you can get this actually this principle actually. So you get this has been used that RTLN gamma B0, not on gamma B0 for this case. When it is Hennian mole fraction, but it is Hennian weight%, additional terms. Complexity, little complicated. 1 weight% converted into this. So this is. So what is this? Answer is this. RTLN, oh, you don't remember, no? Actually, this will help you. This will help you. This part. This part, and if it were Hennian mole fraction, instead of 1 weight%, 1 mole fraction, then only gamma B0. So RTLN will tell me gamma B0 must, in additional term is this part. You check back. The difference between Gaussian standard state I remove this figure, Raoult's standard set and Henrian both these figures actually. So quickly, the time is running out. This is your Raoult's law. This is your Henry's law. This R. This is Henrian standard state. HMF. This symbol I use. This is R. HMF. This point is the and this two. What is the delta G0? What is the difference between Gi bar minus this free energy minus this free energy? This standard minus this standard is what? Again Gi bar minus Gi means arterial activity. What is this line? Remember? Tell me what is the equation of this line? Recall. AB is XP. Oh, sorry. AB is gamma B0 XP. And this equation, and this is AB is XP. This linear part, AB is gamma B0 XP. And when it is XP is 1, it is pure B. XP is 1. So AB is gamma B0. So what is this? Gi bar minus Gi arterial and gamma B0. I would have written if it is mole fraction, but since it is weight percent, where it is? H weight percent. This is actually 1 weight percent. This point is 1 weight percent. This is the second standard set, Henrian. Okay, Henrian mole fraction standard. This is also. But and this relation between this and this will have which term? Not so easy. If it were this, as I tell you, atomic weight, actually this atomic weight of A, I am writing A, the following the trend, following the given equation by atomic weight of A plus 99 atomic weight of B. This you check back, please check this. This minus this or this minus this. All given. And in this deduction, in this derivation, in last last class or 2 classes before, maybe 2 or 3 classes before, you see this difference is used to arrive at this or in inter. Easy. You all discuss. Take this. Now A stands for tell me the solvent or iron, and B stands for vanadium. Happy? Quickly. Your answer is actually close. RT, right. Once more. Ln. Oh, gamma B0. Gamma, what is this? Tell me what B is. B called vanadium. 0. With respect to what you write here, since this is liquid here, so arterial activity, Gi bar minus Gi0, arterial activity with respect to liquid standard state, so the gamma will follow activity. This is another interesting point. Activity with respect to, I repeat, Gi bar minus Gi0 is arterial and AI of this state. Say this one, say suppose for easy consideration, of this state, mole fraction state, standard state, with respect to this one, with respect to here liquid standard state. If activity, this is gives you activity from which you get gamma B0, XP gamma B0, as I told you. If you have Henrian mole fraction, follow the concept with simpler one, mole fraction. Gamma B0, then why it is gamma B0 activity of this with respect to this, which is a respect liquid vanadium, not solid vanadium. Raoult's standard state, but solid. So B for vanadium and vanadium for B and liquid. And this is asked also. See, asked with respect to liquid vanadium as standard. So this you have got. Arterial gamma B0, shall I give a bracket here? Bracket quickly. Atomic weight how much? 56 plus 99. This atomic iron. Vanadium is 51. That's it. And what is how much? Tell me. 8.314. T is how much? Tell me. What temperature? Mention. What is 1600 in centigrade? 1873.
1 hour 54 minutes.
Okay. Okay. So very good. I'll stop because this is another very lengthy. So
5 minutes. How much more?
It check actually, 5 minutes after we check. Okay. So everything is known. What is this? Oh, this is very interesting. Delta G0. Right. Take this. Delta G0 is what? Oh. There is what temperature? Delta G0 at what temperature is RTL and gamma G? Delta G0 T. What is the temperature? 1600 degrees centigrade means delta G0. 1873 is how much? Tell me how much is what? What is how much? Give me this. I substitute. You know this very well. Minus 33080 as a function of temperature given. So substitute. Minus 37.5 times what? 1873. Let me give you this. This is what this values is. Since I've got the values with me. So this is actually I tell you what. This is 37.5. What I wrote 37.57 T. T is what? 1873. So if you do this, I calculated for you minus what? 103,448. 103,448.6 minus 103,448.6. This part, this left hand side. Okay. So what you are getting, I am writing. So minus so I am writing once more. So tidy up. 103,448.6 equals to what you write. Once more you write this. 30 8.314. Write this. 8.314 this side, right hand side, times 1873. Write this full, right. ln gamma B0 liquid full times 56 over 56 plus 99 51 full. Which I am removing from second edition Pascal. Already you know this. Just to make room. This I will be correctly right. Okay. Only one unknown gamma B0. If you solve this or gamma B, do yourself. Gamma vanadium 0. Gamma B0. You remember what is? Henrian activity coefficient at 0 concentration. Okay, gamma B0. That value is how much? This is very important data. Very important. Is how much? Answer you take down. The answer gamma B0 liquid with respect to liquid standard state is what? The symbol is 0.119. 0.119 answer. But people ask me what is this? What is gamma B0 liquid? What is this? This is actually this gamma B0 with respect to liquid volume, and that is liquid means it's okay. Liquid means with respect to liquid volume as liquid B as center state. What is? Gamma B0 liquid, I keep this. This I will actually explain you actually. I have written here. This is gamma B0 with respect to liquid volume. Sorry, I am very sorry. With respect to liquid V vanadium as standard state. So gamma B0 with respect to I keep this one, this one. This part actually I will discuss next class. So this part and what is gamma B0 solid quickly? What is the second one? Gamma B0 solid. Next part. Not B. I have not. Next part. This I will write actually next. So I will keep some space here. this actually with liquid, with respect to liquid V, but with respect to this part actually I'll check this. Next part, but next part is complete. Gamma V0 solid. How to do this? Find next V liquid. Just add these two. Add or subtraction. Just work with this so that you get V solid goes to V weight percent. Instead of liquid, how to get solid? Use this one, this transformation. So quickly. So with V liquid to V 1 weight percent in liquid iron, Indian center state. What is the delta G0? Delta G0 is what? Minus 33080 minus 37.5 T joule. Try to make it solid. So what you write? Write another line. V solid goes to V liquid. Easy. What you know V liquid to V solid is delta G0. V solid to V liquid will be the opposite sign. Delta G0 is what? You write plus, change the sign, 17,600 minus 8.04 T. Happy? Add this together plus, so these cancel. You get the desired relation. V solid goes to V weight 1 weight percent in liquid iron, Indian standard state. What is the delta G0? If you do this, I am giving you the result. I am sorry that I am very close. Delta G0, I don't have much time left. Actually, it's right. What you get this? Minus 861, like this. Sorry, I am very sorry. Minus 15,480. Minus 15,480. What else? Tell me. Minus 45.61 T. Minus 45.
2 hours 2 minutes.
Almost. 55.61 T. This is, you do this, you will get this. So how will solve this problem? Similarly, so what is this? Similarly solve this. So delta G0. So you do this. So delta G0 minus 15,480. What temperatures? 1873. Substitute. Minus 45.61. What's the temperature? 1873. What value? I give you the value. What is the value? Value it is actually 100 minus 100 907.5. Sorry, again put joule here. So this is joule, and what you are getting is what? Start from this point, remove this part. Oh, sorry. Very sorry. So delta G0 is what? I am very sorry. Start. Very sorry. This you remove. This part. Other you will mix up. Delta G0 is what? 1873 is what? Delta G0 1873 is what? Tell me. Minus 100 907.5 is what? Tell me delta G0 is what? Like this. RT ln gamma V0 solid. Gamma V0 solid. Now this time solid because this is solid. Gi bar minus Gi 0 with respect to this standard state. This standard state, okay. So very good. It's okay. I think this is all correct, but still I'll clarify next class about this. Okay. Gamma V0 with respect to liquid volume vanadium as standard state. This part I'll check. I'll clarify once more. Then what? Tell me what is next? What is this? Count is 56. Atomic weight of iron plus 99 atomic weight of vanadium. So what is this? R is 8.314. Temperature is what? 1873. Ln gamma V0. Give a bracket here. By all means, give a bracket. Ln outside. Gamma V0 solid. This is 56 plus.
देखिए बाबा.
No.
Just a minute. Gone. This is blinking. Gone.
Okay. Thank you very much. With this actually I don't have time, so I will take up this plus 99. Let me write this 51. Okay. Or you get gamma V0 solid. Answer I am giving you. Answer, calculate this out. Answer is 0.141. Answer. Thank you. Thank you very much. With this, actually I contributed this to this gamma V0 liquid one with respect to liquid vanadium as standard state, and gamma V0 with respect to solid vanadium as standard state, namely gamma V0 solid. This is the answer, and another answer is the gamma V0 liquid. Both answers of this part A over. Part B I will take up next class, and some clarification I will give. And if this is not recorded well, this concluding few lines, last few lines, concluding 2-3 lines, I will actually repeat them and make it complete. Okay, and make it clear to you. Thank you very much. Thank you very much for your attention and for your interest and for your patience. Thank you. See you next class. Tomorrow, next class is lecture 123 and 24. See you. Thank you. Bye.